Hello, and welcome back to the FAIRe eDNA video tutorial series. My name is Baden Wilms. I'm a research engineer at NOAA AOML in Miami, Florida. And today, myself and Dr. Luke Thompson will be demoing a few of our open source software tools that we've made at our lab that work with the FAIRe eDNA data standard, including FAIReSheets, FAIRe to Chime, and FAIRe to NCBI. And then also, Dr. Thompson will give some assistance on actually filling in your data templates as well. So this video, it's going to be a little bit similar to the previous tutorial on FAIReator because FAIReSheets and FAIReator are very similar tools. So I'm going to start just by opening this graphic that I made. And this just is going over kind of everything we're going to look at today. So you can think of FAIReSheets and FAIReator as kind of the beginning of, your FAIRe eDNA data journey. They both create the FAIRe eDNA metadata templates that you then go ahead and fill in with your data. And they are used as input for all of these downstream tools and more that you see in the bottom half of the graphic. So these are very similar tools to one another, FAIReSheets and FAIReator. We've talked about how they're similar, but now, importantly, we need to talk about how they're different. So first and foremost, FAIReSheets is written in Python and FAIReator is written in R. The second difference would be that FAIReator, as we saw in the last tutorial, creates our FAIRe eDNA data templates in Microsoft Excel, whereas FAIReSheets creates those same templates in Google Drive or Google Sheets. And finally, if you watched the previous tutorial video on FAIReator, you might be confused by these analysis metadata sheets that I've circled here. So FAIReSheets can do the exact same thing, make the exact same templates as FAIReator. However, you can also make FAIRe-NOAA data templates, which are only slightly different than the standard FAIRe format. The key difference between the two, FAIRe and FAIRe-NOAA, is that we actually have moved a lot of these bioinformatics related fields from the project metadata sheet into separate analysis metadata files. And this is just because at NOAA we like to, well, at our lab we like to submit data sets with multiple assays using multiple bioinformatic approaches. And so defining them at project level doesn't suit our needs. So that's really the only difference there. Now, you'll see at the bottom that many of these tools only accept that NOAA format. So that's something to keep in mind when you're thinking about which tools you want to actually use in the FAIRe eDNA kind of atmosphere. But just elaborating a little more about the downstream tools, the FAIRe eDNA kind of atmosphere, I would just like to quickly plug the Ocean DNA Explorer. This is our new Ocean eDNA data portal, and it's a little more than that. It's a visualization and analysis platform built specifically for eDNA. So all the features of it are carefully built, following feedback and input from other eDNA researchers around the world. I would like to say it's not a replacement for OBIS and GBIF, but an additional platform for your data to live on, with data discovery features that are specifically built for eDNA. Things like you can build graphs in the browser, there are great mapping tools, there's a great API, complex search through, a easy to use interface. And so you'll also notice that the input format, the submission format for the Ocean DNA Explorer is the exact same as eDNA to OBIS. So if you're going to plan on submitting to OBIS and GBIF as well, you've already gotten your data in that format, you may as well also submit to the Ocean DNA Explorer. So that is oceandnaexplorer.org. But for today, we are going to be looking at FAIReSheets, FAIRe to QIIME, and FAIRe to NCBI. eDNA to OBIS is actually a future video, a couple more down the line in the series. So I think we are out of the world of concept and theory, and we're ready to run some code. So let's do it. All right, so let's clone down the repository. You can find FAIReSheets directly from the FAIRe eDNA website on the download tab. You can see it right here. And I'm just going to go back here and just show you. This is the AOML Omics GitHub page. So this has all of our open source software tools and code that are related to eDNA research, including FAIReSheets. And I'd like to just mention that the commands I'll be running, the config files that I'll be editing, all of this is described in great detail in the README. So I really keep it up to date. I try to put helpful information in there. So when you go to run all of this yourself, please go ahead and refer to this README. It'll tell you everything you need to know. So we're going to clone down the repository using that link. All right, so we can see it there. That's great. And next, we have to set up our Python environment. So you can do this in two ways. You can either do so using Python virtual environments and pip, and so you'd use the requirements.txt for that, or you can use conda or anaconda and use the environment.yml file. And so that is what we're going to do. Oh, whoops. Need to be in the directory you created. Perfect. And now that that conda environment is set up as it says in the output here, you're just going to want to make sure that your environment is activated. And now we are almost ready to run the code. All right, and one final step before we get into the code, we need to authenticate. Because FAIReSheets is editing files in your Google Drive account, you need to authenticate that it has permission to do so. This process is a little bit manual, and we're hoping that soon it won't be. Once Google verifies FAIReSheets as a Google app, this will be automatic. But for the time being, this process is described in the README of FAIReSheets. So you can see here, just email me. My email is right here at the top, baden.wilms@noaa.gov. And I will send back to you a get gist URL, which it's just going to be a URL that you're going to put in your environment file. So let's do that now. What you're going to want to do is create a file in your FAIReSheets directory called .env. Place it in there. And this is going to store two pieces of information. That first piece of information is the gist URL, or actually copy it like that. And so that's literally what I'm going to send you in the email. So you just paste it in that file. And then it needs a second piece of information, the spreadsheet ID. So we're going to write that. And now you're going to go to your Google Drive and you're going to create a blank Google Sheet. Now, this is how FAIReSheets finds this Google Sheet. It just needs the spreadsheet ID, which is this collection of characters in the URL. So you copy that. We're going to paste it in here. All right, so we are all ready to run FAIReSheets. One last thing to do is customize the template that's going to get built. Now, if you watched the previous tutorial, these parameters will look very familiar. They're very similar to what you give to the R script. And just for your reference, I have a config template file that in the comments explains all of the different options for every field or every parameter in the config file. So I mentioned the standard FAIRe format, and then I also mentioned the FAIRe-NOAA format. I'm going to run FAIReSheets and create one of each of those templates. That'll help you see the differences, and it'll also show you how to run both workflows on FAIReSheets. We're going to do a qPCR or targeted FAIRe template. So we really only need to change a couple parameters. I'll add demo here. We'll have a user-defined field. Why not? And so now, after all that set up, all we have to do is run Python run.py. And this will only happen the first time you run FAIReSheets, but it'll pause and it'll ask you to authenticate in the window that just opened up, which we just saw. So it opens up this window. We choose the account, obviously, that has this Google Sheet in it. And then you just have to click continue a couple times. And then you can see authentication complete, and we can see all the data templates getting built, which is super fun. So this is a PCR, or sorry, this is a qPCR FAIRe template in standard FAIRe format. See all the things, drop downs, everything's there. All right, and so now we're going to run a FAIRe-NOAA metabar coding FAIRe template. So this is just slightly different than what we just did. First, same thing, we're just going to edit the config.yaml file. And I'm just making this easier on myself with a copy paste. And then, secondly, in order to create a FAIRe-NOAA dataset, you have to use the NOAA config YAML file. So you want to set this to true. Actually, I'm going to do the same thing. I have this already ready to go. So you're going to want to set that to true. You got your project ID. And then if you recall, the difference between FAIRe and FAIRe-NOAA is the analysis metadata files. So essentially, you're just putting in your analysis and assay information and saying true that you do want NOAA format. And that's really the only difference. So again, we just run Python run.py. We can see the steps running. And our new FAIRe template getting built. All right, so we can see that that finished up. It opens up this page in your browser, and it's just letting you know some of the next steps that you can do with your FAIRe-NOAA data templates, including that submission to Ocean DNA Explorer or to eDNA to OBIS.
But that is one of the next video tutorials. All right, and I realized during editing that I forgot one last piece to this tutorial, and that is the Google Apps script for FAIReSheets. Now, this is a completely optional part of FAIReSheets, but it does give your newly generated metadata templates some nice new features. So to use it, you're going to go to the README of FAIReSheets, and you're going to scroll down to this large block of code. This is the Google Apps script. So you're just going to want to copy that, go back to your Google Sheet, go to Extensions, App Script, and you're going to paste that code in there and hit Save. Now, your Google Sheets will have a lot of custom features. Um, any edits made will be copied to the README. And there are also some nice data validation checks. Things like required fields have to match each other throughout the sheets that they appear in, and they will get flagged if they do not, as well as other data validation checks, such as if a drop-down field contains an incorrect value. We can see the error there. And now it can also do some more complex features that often get hidden until you refresh the sheet. So keep your eyes just to the right of this Help tab as I refresh the page. And we can see that a menu just popped up called FAIReSheets Tools. And so the app script controls all of these, but you can do some additional things like standardizing your fonts, downloading all your sheets as separate TSV files, which can be nice when you're working with some more tools downstream. And then it can also reorder all of the columns or rows of your metadata sheets, which can be really, really helpful depending on the order in which you fill things in. And so that column reordering is controlled by a simple list in the app script, which is very easy to edit, so you can customize how the fields appear in each sheet. If you include fields that are not in your data, they'll just simply be ignored. So it's pretty error proof. So we're just going to run that real quick. It'll say it'll change the order in these sheets. We will continue. And as you can see, it'll tell you actually all of the different fields that got changed, or moved rather. And yeah, so this one we've moved more mandatory fields to the front, and that can be a really nice, useful tool. So to conclude, I'd just like to thank everyone for listening. In the next tutorial, Dr. Luke Thompson will show you how to fill in these templates with your own data, as well as demoing other tools like FAIRe to Chime and FAIRe to NCBI. Thank you.